beginning. All right. So we have reviewed the micro. Okay. So and then we learn how to measuring, right? So we measuring GDP, measuring price, and measuring labor market. So now this module we are trying to understand so how we make sense of those numbers. Okay. And then the particular is we're trying to understand what to determine GDP. But then, so I want to remind you, so what is macroeconomics about? So the introduction, I say, so macroeconomics essentially is about two things. The first thing is about economic growth, right? So what is the second thing? The second thing is about business cycle. So meaning the fluctuation. Or in other words, so the first priority of our macroeconomics is to understand what gives us long-term prosperity. So if we look at the United States, during the 20th century, our standard of living have increased by 8-fold. What is behind that? So if we look at across countries, so US, the standard of living is significantly higher than most of the other countries in the world. What explains that, right? And actually we sort out, there are a couple of things play a major role. The first one is technology, okay? And the second one is physical capital. And then, so we also find out human capital is very important, labor, right? So actually we have one chapter was devoted to understand the long run economic growth. Or in other words, what brings us long run prosperity, okay? So that's kind of settled. Okay? Oh, by the way, so one way to look at this prosperity is we look at real GDP per person. All right, so this is one aspect. Now, for the rest of this class, so we are going to focus on the short-term fluctuation. Just make sure you understand the difference. One is long-term, it's like a trend. Okay, so like a trend is eventually we are going to have better life from generation to generation, from year to year. But in the short term, so we are going to have fluctuation. We have sunshine and we have rain. We have storm, but we have good weathers. But in our economy, and then so in terms of fluctuation means we have expansion, okay? Meaning economic growth, a low unemployment. But then sometimes we have recession, means so the economy is laying off. So we have collapse of demand, right? So that's what happens. But now, in order to understand this business cycle, how we are going to approach. So the idea is, so we are going to rely on demand side. Okay, so just keep in mind, okay, so we already sort out, right? So first, we are going to focus on the determination of GDP, this is number one. And then number two, so in terms of GDP, so we have long run perspective, and we have short run, long run economic growth, and the short run business cycle is number two. And then number three, so we decide, so we already understand long run, so now we are going to focus on the short run, the fluctuation business cycle, number three. Now, lastly, so in terms of understanding the business cycle, we are going to focus on demand side. But then, so in terms of demand side, remember, so there's an equation. So that's where we are going to base on. The equation says Y equal to C plus I plus G plus NX, right? Where did that equation come from? So actually, so now because, sorry, so actually, so we have three ways to look at GDP, right? So we can look at GDP through product. So like basically what do we produce? We can look at GDP through income. And finally, we can look at GDP through expenditure. So actually in this chapter and pretty much the rest of the chapter, so one particular way we look at the GDP and understand the short-term fluctuation of our GDP is by looking at the demand. When I say demand, essentially we are going to focus on this expenditure approach, right? And furthermore, so remember, so if we ignore the government and ignore the international trade, And then this equation is going to boil down to, let me try to write down, boils down to y equal to c plus I, right? Because as I just said, we simplify, okay? So we just focus on domestic economy and assume there's no government, right? So then so we are going to have y equal to c plus I. So later we are going to expand. But now, so if we understand how c is determined and y I is how I is determined, and then so we can get some determination of this equation, right? So basically, say for example, eventually, as we are going to show in this chapter, okay, let's use this one. As we are going to show in this chapter, c is going to be a function of y, okay, and I is also going to be a function of y. So what this means? This just means mathematically. So this means we are going to have one equation, one unknown, right? And this equation is about y. Or in other words, from this equation, we can determine the level of y. So that is the basic idea, right? So, but then, so before we can determine we can understand the determination of y, the first thing we need to do is to understand what determines c. As you're going to see later, so c is going to determine by the income. But remember, the income essentially is another way to look at a GDP, right? Okay. So that's where we are, right? So, okay, and then, so what are we going to do next? So what are we going to do next? So first things first, we are going to look at this multiplier. But what is multiplier and why we study multiplier? It's largely because in our macroeconomy, so everyone are mutually interdependent. So in the sense, start with households. So households, so they are going to interact with business in the factor market. What that means a household is going to work for business. As a return, the business is going to provide me with income, right? And then, so with the income, the household is going to interact with business again, maybe different business. How? It's because with the income, so we can purchase goods and service, right? But who provides goods and service? The business. So in a sense, we are interdependent. Okay, so we are closely related to each other. Okay, and then in these slides, I'm going to explain to you. So if there's one economic activity happens, okay, and then the net impact on our economy is going to have a ripple effect. Right. So now let's use an example to help you understand this ripple effect, or we call multiplier. And this multiplier is going to help us understand or lay the foundation for the consumption function, right? As I just showed you in the previous slide. So C is going to be a function of income. All right. Okay, we will come back to that equation later. All right. So just go slowly. So first things first. So I need to explain what is multiplier. Okay. Let's just think about, let's use the example, okay? So if UNMC, actually, so recently I was in a meeting and I heard, so UNMC, so they have a plan to build a new hospital with a budget of 1 billion. Okay, that's a lot of money, right? So now let's use this example to understand how one particular economic activity is going to affect aggregate economy, and also show you the idea of multiplier, right? Okay, to simplify the analysis, okay, or to help us understand the issue. So I'm going to make two assumptions or simplification. Number one, so I'm going to say, so UMSC, so this project is going to finish in 1 year. Okay, so we don't dealing with like overtime. All right, so this is going to finish in 2022. This is number one. And number two, further, I'm going to assume if UMC starts to do this project, everything in terms of material, in terms of labor they hire, okay, and in terms of service they purchase, everything is coming from Omaha. Or in other words, there's no like international trade. All right, to simplify the analysis. Now the question is, for us for the moment, the immediate question is, what would be the impact of this hospital project on local economy of Omaha? So that's our question. To answer that question, or to understand these particular questions, let's go step by step. So if they got money from some donors with 1 billion, they finish this project in 1 year. So immediately, so that is going to increase the GDP by exactly 1 billion, right? Because they need to hire workers, right? They need to purchase materials to build a building, right? Physical building. So that essentially they are immediately create $1 billion of purchase of goods and service, right? So this is 1 million. But now, do you think the story is going to end up there or no? Certainly not, right? So once they spend this 1 billion, and immediately means, because I just simplified the analysis, says everything happens inside Omaha. So that means what? That means somebody, some business in this town, so they get this 1 billion, right? And now with this 1 billion, what they can do? Let's say, for example, so if one of our students who is a computer science background, okay, and who is very good, who is expert in this like network building, and so was hired by this project and receive, let's just simplify, okay, receive 1 million, okay, that's income. And then just put yourself in the shoes of that student. So in 2022, okay, so you got a job because of this hospital project, and this job brings you $1 million income, okay? What are you going to do? So naturally, you're going to spend some, right? But how much you're going to spend? Usually it's between 0 and 1 million, right? Okay. So you're going to spend, let's just simplify, you spend 80%, right? So if you spend 80%, which amounts to 800,000, all right? Okay, so we just simplify it. The analysis just says, okay, so we are going to only consume inside Omaha, right? So now, so this 800 million, 800,000 out of this 1 million, what does this means to Omaha economy? So this is on top of the 1 billion we just mentioned, right? Right. So now, because someone received income, and then with this new income, so you're going to spend. You spend 80%, right? So this 80% of spending out of the new income is going to generate new demand to local economy, right? So actually, so this story can keep moving, okay? Because so it's a example. So the first individual received 1 million, spend 80%. I don't know what he or she is going to spend. Maybe so she or he is like buy a new house, right? And then so the developer has additional 800,000 of income. And then the developer is going to spend a fraction of these 800,000, right? So maybe buy a fancy car. So you can see there's like a ripple effect or like a domino effect. Okay, so because the entire economy is interdependent, because one person's expenditure becomes other person's income. right? So you can see this is going to keep moving. Right? And this process essentially is a multiplier. Okay, so now to understand the net impact of this multiplier effect, the key concept is called marginal propensity to consumer, or MPC. So we define MPC as essentially is a percentage of your disposable income, the new disposable income you're going to spend. So if you have $1 of increase in your disposable income, if you spend 60 cents, so that just means you have an MPC of 0.6. Okay? Usually on average, so we have an MPC between 0 and 1. Okay? So let me explain to you what this means. Think about extreme example. 1 means what? Means, so I'm going to spend any penny I earn. I don't save. This is 1. 0 means for each penny I earn, additional penny, I'm not going to spend, I'm going to save. Okay, so 0 and 1. But then sometimes you have negative. But what is negative? Negative means, so if I have earned $1, sorry, so negative is rare, okay? So greater than 1 probably is easier to understand. So greater than 1 means if I earn $1, I'm going to spend more than $1 through borrowing. Okay, but usually it's between 0 and 1, and the clause, remember, this is a macroeconomic clause. Okay, so macroeconomic clause, usually when we say this number, usually just look at the average. Right? So in our society or among your friends and family, so you may see someone MPC close to 0, meaning save a lot, and someone MPC close to 1 means spend a lot. And usually old people save more and younger people spend more, right? But then in the average, so this number tends to constant, all right? So, or in other words, we look at national average for our analysis, but this coming from individual. Okay, so and this MPC play a major role to understand the impact of multiplier. Remember earlier in the example we said someone who receives income, and he or she is going to spend a fraction, right? And this additional spending or this fraction of spending is going to have a ripple effect throughout the economy. All right, and then so now let's see what happens. Oh, by the way, so here, so there's a corresponding concept. It's called MPS. So MPS is a fraction of the original income you put to saving. But then so naturally by construction, so MPS plus MPC, they should equal to 1. The intuition is any penny you earn, you either save or consume, right? So that's only 2 ways to exhaust your income. Some students may say, okay, I'm going to donate. So donation usually is considered as like a consumption, right? And then someone say, okay, so what happens if I lost my money? Steal by someone. Okay, usually we say let's just put in that consumption to simplify, right? Because that's the way you understand. Okay. All right. So given this MPC, now we can understand the multiplier effect, right? So the story goes as follows. If we initiate a $100 billion investment, or in the early example, show you if UNMC decide to build new hospital, which costs $1 billion. Or like if you look at bigger picture, so President Biden, okay, so sign into law a big infrastructure plan. Is going to spend significant $1 trillion to renovate highway system, to bring us new energy, so on and so forth. Now the question is, what would be the net impact on our economy? At this point, I hope you understand certainly the net number is going to be bigger than 1 trillion or 100 billion or 1 billion. So in 3 different examples, right? but how large? So that's what we need to find out. So the story goes as follows. So initially, so immediately you have this impact, right? Because you have a project. You need to purchase goods and service to finish this project, right? So this is initial. Now, next. So this 100 billion is becomes to someone's income, right? Either it's like smaller scale. So I spend $100 to buy a bicycle, okay? So I spend $100. That becomes somebody else's income. And we can look at intermediate level. So you and MPC spend 1 billion to build a hospital. And this 1 billion is going to earn by local business, right? So whoever has the chance to work for this project. And then we can look at the ultimate level. So President Biden initiate a 1 trillion infrastructure plan. So this 1 trillion eventually goes to someone, right? So maybe millions of contractors, right? Okay, and so that should immediately increase our demand by the amount you initiated, right? Okay, so this is 100 billion in this case. Now, this 100 billion becomes somebody else's income. And then somebody else, quote unquote, in the economy who received this income, what she or he is going to do. So he or she has a MPC. Usually it's between 0 and 1. Means she or he is going to spend a fraction of this 100 billion. And then so exactly how much that's equal to MPC times 100, right? But this story won't stop here. And then so the second person or the third person is going to receive this amount, right? And then you can see this machinery is going to keep moving, okay? It's keep moving. So there's no end because our economy is so enormous. Our economy is completely interlocked, right? So it's never end. And then, so the total impact on our real GDP will be equal to 1. That refers to the initial spending. MPC, that's the first person who received money from this big project, and it spent a fraction. MP squared, so that's the second person, and so on and so forth, right? So how we are going to get this number inside this parentheses? Okay, so if you don't follow the math, don't worry. Okay, so this is not mathematical class. So what matters is you understand why we can write this equation. Number 1. Number 2, you remember. So from this equality, we can get this equality. Whether you can derive or not, so that's not crucial. Okay. You end up with 1 over 1 minus MPC. So that is the multiplier, all right? So here are a few things I need to emphasize. Number 1, for the moment, this is a oversimplified model. So in reality, it's more complicated, okay? So I named a few, but we will pick up that in later chapters, okay? So first, the money we received from the initial project or in any round, the way you spend, it matters. It does not necessarily means you're going to purchase goods and services produced domestically, right? Think about Omaha. So someone who received money from this project, they may go to Council Bluffs to spend, right? Or even go to Georgia or Minnesota to spend, right? So that means, so the impact on the Omaha economy is going to decrease. The same logic goes to larger level. So this is number 1. The number 2, the money you receive, usually you have to pay tax, okay? Meaning, so like here, so this the second round, someone received 100 billion, but actually, so his or her disposable income is less than 100 billion because she or he has to pay tax, right? So those are the two things you want to keep in mind. And then finally, so how the government, I mean, if you think about the government, how the government spend the money matters, right? So like here, so you say the government just spend the money to purchase goods and service, right? So meaning, so like President Biden says, okay, so I'm going to spend 1 trillion to renovate the road. But however, if this 1 trillion is used to give you free money, like civic income, so I believe most of us receive the credit from the government, right? Because this is a care tax, right? So then the impact is going to be different. But nevertheless, we are going to pick up that in later chapter, right? Okay. And finally, let me highlight the MPC and this multiplier through extreme examples to help you understand. Okay. So now just imagine if MPC equal to 1. MPC equal to 1. What does this mean to this multiplier? Mathematically, if MPC equal to 1, and then this number goes to infinity, right? Because essentially you use 1 divided by 0, or 1 divided by a number close to 0. So that's going to explode, okay? But economically, what this means? It just means, okay, so we have initial project. We spent, yes, we spent. We increase the GDP. Now, the second person has this income, but the second person is going to spend all the money they earn. And you can see, so there's no loss throughout the process. And this process is going to keep moving, right? We just keep adding up the exact amount we initially start with, okay? So this is if we have MPC equal to 1, and then this multiplier is going to be infinity, means we can simply initiate something randomly and then just keep our wheel spinning, right? So this is one way to understand. And then, so now the other extreme case, if MPC equals 0, what this means? It means mathematically first, this just means multiplier equal to 1. 1 just means there's no multiplying effect, right? So because, and then economically it just means, so we initiate an initial round of spending, and it's going to immediately stop there, because whoever receives income is not going to spend. So this is how you understand 0 and 1, right? So this multiplier effect has profound policy implications for most modern economy, right? Or in other words, in our current world, most central government. So they relies on this multiplier to rescue the economy or to regulate the economy, okay? So whenever we have a recession, usually the government is going to increase spending so that they can rely on this multiplier to increase the total GDP. In the extreme version of this multiplier, okay, someone advocate. So whenever we have a recession, what we can do is we are going to hire someone to dig a hole on our highway. And then, so we hire somebody else to fix that hole. And then immediately we are going to generate two jobs. And then so you're going to have multiplier. Okay, so this is an extreme version of this multiplier, but I just loosely explain the idea, right? So you create this spending, and then so you have this ripple effect, right? So we will come back later, okay? All right, so now here, there is a quick discussion, right? So I'm going to give you 1 minute for you to work out, okay? So basically, so what I want you to do, this is just a practice because I already give examples. Here, what I want you to do is just to come up an example on your own to understand this ripple effect, right? So the starting point is in our economy. So we have an increase of investment spending by $200. Okay. Now you need to come up with some examples yourself to see how the second and the third and fourth person is going to do throughout this economy, and then find out what is going to be the net impact on our total GDP. Right? I give you one minute to work through. Right? Okay. So let's just look at these together, right? So here, in these practice questions, so we have MPS of 0.2. That means the MPC will equal to 0.8 because MPC and MPS must add up equal to 1. Okay. So MPC equal to 0.8 means for each additional dollar I receive, I'm going to spend 80 cents. Now, what happens in this example? Initially, we increase investment spending of 200. Actually, what I want you to think about is just come up with examples. And here you may can think about, okay, someone to decide to buy I don't know, $200, what you can buy. You can buy a bicycle maybe, okay? So this is 200. And then immediately, so the total increase in GDP equal to 200. So the first round is 200. Now this 200 becomes somebody else's income. So whoever sold the bicycle. So now the person who received $200 is going to spend a fraction. MPC times 200, which is 160, right? And then what this person is going to do, so we can just come on some examples. So this person is going to have big dinners at a local restaurant. Okay, so this is 160. Now, the third round, the restaurant owners with this additional 160 income is going to do something else. Okay, so maybe it's going to buy some flour of 128, right? And from a local gardener, okay? And then so you can see things are going to keep moving. And then what we are going to do is we're going to add them together. So eventually we are going to end up with this formula. So this 1/1 minus MPC, that's a multiplier. So actually that equal to 1 plus MPC plus MPC squared plus MPC cube, so on and so forth. Okay, and then we plug in the number, we get the total increase in real GDP equal to 1,000. All right, so this example. All right, and to finish this part, so we have autonomous change in aggregate spending. So if we define this, so this just says, okay, so if the economy has an increase in or decrease in aggregate spending, right? So what will happen to change in real GDP? their relationship is going to characterize by this formula. But essentially, the first term is the multiplier. But also inversely, we can just define the multiplier as the response of total GDP to increase in autonomous change in aggregate spending. Right. Okay, so now before I move to the consumption function, now let's look at this practice question. Holding everything else constant in the economy, the larger the MPS, the question asks you, what happened to the value of multiplier? So there are two parts, right? Number one, MPC plus MPS equal to 1. This is number one. And number two, multiplier equal to 1 over 1 minus MPC. All right, so there are two equations. So if we have larger MPS, the first equation is going to tell you, so the MPC is going to smaller, right? Now with a smaller MPC, the second equation is going to tell you the multiplier is going to smaller. Okay, so the answer is A. So we can look at this case study to understand the implication of this multiplier. So here we look at our economy during the time period from 2006 to 2010. What happened during that time period? So our economy was facing the worst recession. It's called a global financial crisis. Okay? And that crisis was largely intrigued or largely caused by the collapse of housing market. Right? Okay, so before we understand this figure or these numbers, now ask yourself, so inside the United States, which state relies more on housing sector? If we compare Arizona versus Nebraska, which one do you think have a booming housing market? Nebraska or Arizona? So the answer is usually Arizona, right? For a couple of reasons. So one reason is, I think the major reason is Arizona has nicer weather. Okay, and so they have denser population, higher demand to their house, right? Okay, so now our multiplier is going to kick in. First, look at the change in construction job. So this is without multiplier, right? So if there's a collapse in housing market, and then there are more people who's going to lose a job. So on here, so we have sand state versus non-sand state. By the way, here, sand state essentially just refers to Arizona, Florida, or even California, where they have beaches, right? Sunshine, better weathers. So they have attract lots of house building, right? Okay. So because of the collapse of the housing market, sand state, they relies more, or they have larger housing sectors. So the collapse in construction is going to more significant than non-sand state. Okay, so this is very intuitive. Now, if we look at right-hand side, so this is less intuitive, but that just relies on the multiplier we just discussed today. So on the right-hand side, or this part, we look at changes in employment among non-construction sector. But why the non-construction sector also impact? It's because, so people who in this construction sector, they lost their job, they lose their income. And then, so they are going to reduce their spending. So that's going to have a ripple effect, all right? But certainly the ripple effect is larger in sand state compared to non-sand state. Because in sand state, so they have a bigger housing sector. So the ripple effect is even larger. All right, Okay, so with those preparation, we can look at consumer spending. And remember, at the beginning of the class, I was explaining to you, we try to understand what determines the total GDP. And then we are going to rely on equation y equal to c plus I. Okay, because we simplify. For the moment, we just ignore government. And we are in a closed economy. But then in terms of C and I, so we try to understand how C is going to respond to your income. Actually, this is kind of written in this slide, right? So households, so their income, their consumption depends mostly on income, right? So the reason why we focus on the relationship between consumption and income, there are two reasons. Number one, because at the end, so we want to type down everything to income, or because income essentially just tells the GDP, right? And secondly, so empirically find out, so income is the main driver of our consumption. Okay. So if we look at this diagram, okay. So what we have in this diagram, this diagram, in order to understand this diagram, first, this is for the US economy. Second, so we look at our economy in 2013. Okay, so we can do a similar exercise for other year. So you can think about 2020, 2021, or even 19 something. Okay, so this is the first thing. Now, what we're trying to do here is we look at individuals. Okay, so each dot represent American households. So we ask, what is their current disposable income? And we also ask, what is their current year spending? But what is current disposable income? Essentially is the household's total income. This is including wage, including rental income, including capital gain. All right. And then, so we need to subtract tax they paid and add the transfer. Think about sometimes someone may get transfer for child credit, or somebody else may have transfer in the form of Social Security, right? So this is your disposable income on the horizontal line. On the vertical line, so we have spending. So this is total household spending, right? So this spending includes housing, includes transportation, includes food and beverage, education, and many other things, right? So those are the two variables. For each household, we gather these two data and then put them in this diagram. But what do we observe from this diagram? So there are a couple of things. Okay. First, the most noticeable observation we can make is that the higher your income, the larger your consumer spending, right? So this is number one. Or in other words, so this relationship is positive. It's number one. Okay. And number two, so that if we plot a line, this is almost a straight line, right? And the straight line means, so the slope of this line is constant. But then, so you may want to ask yourself, what does the slope of this line means? So the slope, by the way, so we can look at the slope. The slope just tells you, so if your disposable income increased by 1 unit, and then so your consumer spending increased by how much? Right, so mathematically. But if you write down this mathematical equation, so your change in consumer spending divided by change in disposable income, that exactly gives us the MPC, right? So then, so this data point just tells us for the American households, so MPC is almost constant, right? It's positive. The second observation. Now the third observation. So if we look at consumer spending with a disposable income of 0, is the consumer spending positive, negative, or 0? So it's fairly easy to find out, right? So actually, so if someone has a disposable income of 0, the consumer spending will be positive. Okay, but how we understand that? What is that particular amount of consumer spending if someone making 0 disposable income? Okay. So that's the question. The answer to that is, so this amount of spending is called autonomous spending. So this is spending regardless of your income level. And in reality, this just refers to spending we must carry out to survive. Right? So think about the basic shelter, the basic food, and the clothing. All right. So now with all this preparation observation, so we can define this consumption function. So the consumption function is an equation showing how individual households' consumer spending is going to change with households' disposable income, right? And then we can write this in a nice way. Okay, so on the left-hand side, we have households spending. Okay, so this household spending includes many things, right? Housing, transportation, food, education, entertainment, travel, right? Many things. Now on the right-hand side, first of all, C is going to depending on your disposable income. And secondly, so right here, YD is a disposable income. Okay. And secondly, so the relationship is positive and it's related, and C is related with YD by MPC. So if I increase my disposable income by $1, then my consumption is going to increase by MPC dollar. All right. And finally, we have A. So this is a constant. This is a autonomous consumer spending. And explain what a family would spend even with 0 income. Okay, like I just explained. So this refers to the consumption to make sure you can survive, right? And actually, you may ask yourself, will this A varies with country or not? Okay, will this A varies with time or not? Okay, so this is a question you may think about. Right. So now, so we can do some algebra. Okay, we can do some algebra. But essentially, they just kind of reinforce what I just explained. Okay? So MPC equal to delta C divided by your disposable income. All right, and then so we just multiply both sides by changing disposable income. Now we get right-hand side delta C equal to left-hand side, right? So essentially, just says if your disposable income goes up by $1, your consumption is going to go up by MPC dollar, right? So now let's finish this part by looking at some practice questions. Okay. Okay, look at this one. Suppose Sue's disposable income is 10,000. She spent 8,000. And when her disposable income is 20,000, she spent 14,000. The question asks you, what is her autonomous consumer spending? And what is her MPC? Okay. So I'll give you 1 minute to think about, and then so we can work on this together, all right? All right, so let's look at these together. So I just write down the information here. Okay, so if your income or if Sue's income is 10,000 and she's going to spend 8,000. If her income is 20,000, she's going to spend 14,000. All right. And then so we just learned this equation, C equals A plus MPC times YD. Okay. And so what are we going to work out this? First, we need to find out what is MPC, right? But then, so MPC, how are we going to get MPC? So the MPC is going to equal to change in consumption divided by change in income, right? Sorry. So then, so here, so MPC equal to, so I lose my pointer. Anyway, so MPC equal to 10,000 minus 8,000. So which is change in consumption equal to 2,000 divided by 20,000 minus 14,000, which is change in disposable income, which is 6,000, right? 2,000 divided by 6,000. Okay. Wait a second, sorry. I'm wrong. Sorry. So change in consumption is 14,000 minus 8,000. That's change in consumption, which is 6,000. Change in income is 20,000 minus 10,000, which is 10,000. So MPC equal to 6,000 divided by 10,000, which equal to 0.6, right? So now 0.6. So that just means MPS equal to 1 minus 0.6 equal to 0.4, right? So this is MPS. Now, how we are going to find out autonomous consumer spending? And then so we are going to rely on the equation I just wrote on the whiteboard. So C equals A plus MPC times YD. And then we just plug in one of the observations. So for example, you plug in the first observation. So when your income is 10,000, you consume 8,000. And then so you have one equation, which is 8,000, which is C, equal to A plus 0.6, which is MPC, times 1,000, right? And then so we can easily to get the autonomous spending equal to 2,000.